Regression analysis is a powerful tool for examining the relationship between variables. Using regression analysis on big data allows confident determination of which variables impact a particular topic of interest. After viewing the relationship of variables from the correlation analysis, prediction of future outcomes can be performed. We have used correlation and regression analysis on historical data from students who have taken ACC 200 to predict possible total grades for future students taking the same course at USM. Based on correlation results and the regression analysis, students who do well on exams 2, 3, 4, and the Chapter 11 pre-lecture have the potential to pass ACC 200 with an A. Students can also use the regression equation to determine the lowest possible scores that will still result in a final passing grade.
Give me a second, I'm going to turn the transcription off. All right, so when we were given the original set of data, we found there were certain numbers in there that had just blanks, certain cells that didn't have any information in there. That's information that if we had kept in there, it would have made our analysis have errors in it. We couldn't have run the data analysis. So the first step in any kind of data is analyzing it for corrections that need to be made. We turn those blank cells into zeros because if they're blank on grades, you get a 0 for the assignment. So after we did that, we started to look at what we wanted to predict with it. What's going to give us the most accurate results? So for the specific one that we chose, we went with taking out anybody that had a 0 on every single assignment from exam 2 and on. So what that kind of showed us was that they gave up halfway through. So they got to exam 2 and then they didn't submit any assignments after that. Our determination with that was that those students probably did not want to finish the class. Our opinion on it was that if we kept them in there, it would have skewed our results a little bit and driven that analysis at a lower grade average. So we took out all the students that had zeros after exam 2. Once we did that, it actually moved our class average grade from a 65.4 up to a 74.4. So we see some progression there, but once we have that removed, we can start with, going forward with the correlation analysis. Now with manipulating the data, it's all very opinionated. It's every single one of us had a completely different regression choice to make. So the one that we went with was all after exam 2. I know that I personally made one that was remove any students who had zeros on 7 or more assignments. Sherry, you'd left everything because in your opinion, everybody's a factor in this equation, and each one gives us different results. But again, very opinionated on what you can choose to do and what you think is going to give the most accurate representation for the equation that we're trying to solve for. So for our main one, again, everyone that had a 0 after exam 2 got taken out and everybody else was a factor in the equation. And once you kind of manipulate the data and you go from there, that's when you start and run the correlation analysis.
Okay, so yeah, after we clean up our data, the next step is going to be conducting your correlational analysis. The biggest problem with big data is just that, it's big data. You can get these overwhelming data sets that there's no way to even work with them. There's no way to even know if it's relevant. You may have variables that look incredibly relevant that if you actually sit down and analyze, well, they're not related at all. My favorite example of that is that ice cream sales and shark attacks are extremely highly correlated. But I don't think that has anything to do with how much sharks like ice cream. I think it has more to do with how many people are on the beach buying ice cream when there's shark attacks. So there are variables, like Brianna said, that you have to use a person to filter out. You have to know that, well, that doesn't make sense. For the rest of them, since you're dealing with such big data sets, what you need to do is run your correlational analysis, which is on Excel under your data analysis. And it's going to tell you how much each variable you're looking at is related to your independent variable that you're trying to figure out. You need to understand what your coefficients mean. Anything from 0.5 and under, or 0.3 and under especially, is considered not relevant and not something to use. 0.5 to 0.7 is considered usable. 0.7 and above is desirable. So you really want to look for those coefficients with 0.7. And like mentioned earlier, we ran multiple versions. We had correlations of anywhere from 0.3 all the way up to 0.9. The most common were for exams 2, exam 3, and 4. And my notes state that we had coefficients anywhere from 0.71 all the way up to 0.91 on these given 3. The fourth variable varied depending on your cleaning technique, and that was either exam 4 or chapter 11. With Brooks, who we decided that she had the best cleaning technique, so we went with her analysis, turned out to be chapter 11. And we didn't have any relationship between the 4 variables, which Spencer is going to talk about for us.
So yeah, after the correlations, we look at the multi-collinearity, I believe. And correlation is more of what, like, finding what doesn't necessarily connect, and multi-collinearity kind of finds what connects or what works too closely together. So if you have one thing, you don't want it to be changing the exact same way as another one, or else you're not going to ever be able to predict that what this one thing, how much that's weighted. So if you have 2 things that are changing the exact way, it's going to be affecting it. 2 things are going to be affecting one thing at the same time, and you don't want that. So this kind of works out in like a bad way when you're looking at big data, because you have so much, you're going to have a lot of correlation. But it also kind of works out for if you don't have the means to deal with big data as a whole, because you're kind of forced to go through and cut all these extra numbers you don't need, because it's all this one thing anyway. It's all going to affect it the same way.
Okay, I see. So you're just so I get this, Spencer, you're saying, like, if you have 2 points that are closely related, they're not independent of each other, you need to screen one of them out as well.
Right, exactly.
Okay, all right, I'm with you. All right, well, I'm going to kind of take a step back, just talk about first just linear regression as a whole. Not all data sets are going to follow this. We're trying to look at it as almost like a normal distribution, which is a bell-shaped curve. I'm not going to bore you with all the details of that, but there are some certain assumptions that we need to make sure that we're following. Otherwise, our results will be somewhat meaningless. But it looks like this data has a really good pattern. With the exception of all the 0 clusters down at the lower end of the curve, which those were pretty well screened out through Brooks' analysis. So they didn't skew our data as much. And I think that's why we end up coming up with such a good R-square, which I'll talk about in a minute. But as it relates to big data, we talked about in our last assignment that, we were in the Bed Bath & Beyond example that, perhaps the younger consumers or the younger generation that are purchasing products from Bed Bath & Beyond, they're not so much coupon users as, the older generation. So we could use this type of analysis to kind of thresh that out and see, send out coupons and target them to specific younger age groups, and then track those coupons to see if they return back to the store. And through that type of analysis, we can nail down the question: are we really kind of out of touch with the times, or is Bed Bath & Beyond out of touch with the times, and maybe they should use some other type of marketing mechanism to bring in younger shoppers? So anyway, let me get into specifics of the multiple regression or the linear regression that we did settle on. And basically, Brooke had the approach that we all agreed was probably the best approach, where anyone who scored a 0 on an exam after exam 2 was thought of as not really trying very hard in the class, and that their data should be screened out. So once that was done, and the correlation analysis was run, there were 4 exercises or exams that weighed in on our choice for our dependent variables. Our independent variables for the linear regression analysis. And those were exam 2, exam 3, the pre-lecture on chapter 11, and exam 4. And all of these had values greater than 0.7. So once that regression was run, the R squared, which tells us kind of the goodness of fit. I mean, so if you have a perfect fit, an R squared is going to be 1. You know, so the closer you can get to 1, the better fit that you have, the less scatter of data that you have, and that gives you more confidence in your result. So with Brooks' equation here, or with her analysis, linear regression analysis, she had a 95% R squared. That's really good, and it ends up that her equation is very predictable. If someone wants to make a let's say, for example, an 80 on the test, well, then they've got they're probably going to overachieve. They're going to make closer to 100 on the class. If someone wants to make a 90, of course, they'll be over that as well. So so anyway, I don't have the specific formula written out here, but come back to me in a minute and I'll tell you what that is.
I know I was going to kind of help wrap this all up with comparing and contrasting everybody's different approach. I know Brianna and Brooke, you guys deleted certain students after a particular point. I know Sherry, you had kept everybody in. And I guess moving forward, we need to just kind of think how we can apply this big data to our next big group thing. We also can look back, like Tim had previously mentioned, with our last meeting and try and go over everybody's subjective approach to those particular companies being able to utilize big data. If they're looking at certain types of customers, if they're looking at certain demographics, whatever, how are they going to be able to use big data in the big picture? And I think that's going to be the best part for us to move forward in the next step too, is how are we going to approach gathering big data and utilizing it to find what we need.
Absolutely.
And I also know, like, when we start working on our big data, not specifically for this accounting grades, and we look at bigger data sets, you know, like Walmart, Target's data sets, Bed Bath & Beyond, there's going to be a lot more factors that we're going to have to play into. And I noticed too with previous people's regression analysis that a lot of their stuff wasn't correlating to 0.7 and above. So if it comes down to something like that, we might have to look at, well, should we lower it, or should we look at different independent variables to search for that would give us that higher, you know,
that's
correlation with
alluding
it.
to with like the bigger companies like the Targets and things like that. You know, what specific independent variables are they using in order to get such perfect, you know, correlations and everything? So we'll have to really think about how that gets applied in real life and how we can go out and look for that data.
Absolutely.
Did you find your formula, Tim?
Yeah, I think I've. Okay, so basically, you know, with the intercept that she has, I mean, it's weighted. Let's say you make a 0 on the exam, you're weighted at getting a 16 for the class. So it's a little bit skewed, but you know, as you apply that to the whole data set, that's why it makes it look like we can make, you know, for example, like I said, an 80 on if that's your desired grade for the class. You end up with 108% average. So that would explain where our intercept falls kind of explains that a little bit.
Absolutely.
I think the biggest takeaway we all got from this is interpretation is subjective and personal. We all looked at the data and got our own different variables and outcomes. So the biggest takeaway for me is how is a company going to perceive the data versus how each individual perceives the data?
Yeah, I agree with that. And what seems clear to me is when all those zeros that we had kind of in the data set, that really skewed the data and didn't make it very useful. So that I didn't initially screen all that stuff out when I was doing mine, but as we've discussed this more, it becomes apparent to me that that's really the right approach, is to go ahead and get all that zero data out. I mean, someone may make it zero by, attempting to take the test in an honest manner and they just score zero, but that's pretty unlikely. And certainly all the clusters of zeros that we have is extremely unlikely, and those should be tossed out.
And we relate our personal experiences too. I mean, we've all taken Accounting 200. We've all taken accounting classes. And I don't know about you guys, but I know I didn't stop halfway through and not submit anymore after that.
Mhm.
So
Like I said earlier too, that just makes it all personal preference and what we all think the independent variables we should be looking at are. So it's very interesting to see just how the same data varies between each and every one of us.
absolutely.
Mhm.
All right. Well, I'm looking forward to the next project and looking at outside companies.
All right.
All
Well,
right.
we'll see you then.
So thank you guys.
Yeah.
Thank you.
Yay. Done.